So here bootstrap program, okay, is stored in ROM. Okay, so your boot block initializes the system. So in the sector 0 will actually have a boot code. Okay, so bootstrap program is there in ROM, which is actually telling to run the code, which is directing, okay, your initializes your boot code which is there in your sector 0, and it will tell how to get start with the thing so that the operating system is getting loaded into your RAM. Okay, so you have bootstrap loader program, which is nothing but, okay, which is there in your ROM. Okay, so if you have sometimes, okay, bad blocks, okay, so blocks, okay, which are not usable, because sometimes what happens, sometimes if we scratch the surface of the disk, okay, so no information can be written on the disk. Okay, so in that case those information are called as a bad blocks. Okay, so operating system is having sector sparing kind of technique to handle the bad blocks. So that means it is keeping some free blocks, so where, okay, to handle whenever there is some problem of your bad blocks and all, so it is going to use that spared sectors, okay, which is kept, okay, so to handle the bad blocks. Okay, and then swap space management. So swap space management, so virtual memory uses disk space as an extension of your main memory. Okay, so you know that virtual memory concept, the program which is even the larger than the size of your main memory can be executed. Okay, so how does it execute? Because we know that the space is kept on a RAM. So here what happens, so virtual memory concept may be implemented using the paging technique. So only the required pages are brought in the main memory for execution. So in that case what happens, so it needs to keep the entire rest of the program into your hard disk. Okay, so if any page is demanded, then it has to immediately get it from the separate space called as a swap space, so that it doesn't take time to search on the hard disk and then get it. So it is better to keep a separate space reserved from where it is going to get the pages. So that is called as a swap space. Okay, so swap space can be carved out in normal file system. So that means some space which is kept in the normal file system itself, or you can also have a separate disk partitions in your swap space. Okay, so Berkeley, this example, okay, Berkeley, which is holding a text segment and the data segment. Okay, so separately it keeps space for text, and separately it keeps a space for data segment in a swap space. So kernel uses swap max to track the swap spaces. So this is how we are going to manage the swap space. So this completes this particular chapter.